And looks like we're live. So welcome guys. Today we're gonna be working on our Holy Abstractive Programming Language. By me, we're gonna yeah. Alright, that's better now. We are gonna write our documentation website on my programming language. So let's get started. I'm also gonna be start recording. Well, that's great. So now I'm just gonna do this. Alright, let's start our Pomodoro timer. It works. Now let's go back in here and open some music. That's great. Yeah, I could just start. So, where is my alright. So I'm just gonna go to CodeBark to my repository and all the APL docs. There we go. Oh, we didn't update it actually. We gotta go to GitLab, unfortunately. Oh, git pull. Nope, can't do that. There we go. Code SSH git ls src git clone all the APL docs. So it's a white press app. Right. Let's open our Visual Studio Code in here. So firstly, git push. We're gonna add the CodeBark repository git promote auth CodeBark. Alright. Git push CodeBark. We're on main. Yeah, everything is up to date. So I guess it's working. So I want to open my Joplin. Is it going to be open? Yeah. Right. So we have a lot of stuff to implement. Let me wait a little bit more. So we have an introduction. So what is that? Let's open doc stuff. Somebody came into our stream. Nope. That's great. Alright. So what is the abstractive programming theory? So it's just So every computational entity is an explicit and abstraction of some real-world or conceptual object. So the core principles are universal abstraction. Yeah. So I'll just I can't do that. I'm just gonna work. Let's go to documentation. Advanced basics. We have get started section here. I think so. Guide, getting started. So let's open here. So we have what is abstractive programming session. It's working. We have why and cons and pros. We don't have that. So where we're gonna go is white press and config, and nope, not in here. Cons and pros, yeah, there it is. So we're gonna reload it back again. Holy APL, done. Alright, that works fine. So we gotta go to core concepts right now. So we are going into the basics and the core concepts. I have a note for that, and core concepts. Nope, not in here. Core concept. Oh, it's in somewhere in here. Compiler. Nope. Programming. And the Turing complete. Yeah, there's the basic stuffs in here. Well, I'm just gonna go and paste it on here, and it seems like it's not working. What's the problem? Oh, so I guess we gotta, I don't know, how could we import images? So importing images and white press. Let's ask. Oh my god, dudes, haven't caught up the streams. How's everything going? Everything is going well. I have a project on, let me show you. I have a project, I have an OS project, and it's gonna be an ExoKernel. So there is Linux kernel, there is React OS kernel, which is actually just open source Windows, and there's our microkernel. So let me think of it. Linux, Windows, and it connects into a kernel, it contacts into another kernel. So it's an ExoKernel. It's a meta system. So where was our note? I don't see it in here. RISC-V tutorials, roadmap, kernel stuff. There was. I guess I didn't save it. Wait a minute. Maybe it's on the files. A little too dumb to understand. All right. I'm writing my own programming language for my own kernel running inside of my own ExoKernel, an upper kernel API for kernel. So I'll show you, but I can't find it. So maybe we need a Kurita or something like that. Paint.js. Paint.js. There you go. So I think it should work, or maybe a modern alternative. gspaint.org. Paint.js view demo. Alright, that will work. So we have a kernel in here. So it's Linux. So we also have the React OS, which is React. It's just Windows, by the way. It's open source Windows. And we also have a microkernel in here. So it all binds together in one kernel. So you can run Linux applications, Windows applications, and my Zen kernel, Zenith. I still don't know what I'm gonna say about that. I'm just gonna say holy microkernel, HMK right now, and it's the system. So that's it. Sounds like something my classmate would do. He wrote Linux in Golang, his own language for prep project. It's just not something like that. So I'll show you the programming language itself. So this is how you wrote it, how you write it. So every computational entity is an abstraction. So for example, the variables, the functions, or the types are just an abstraction of something. There is some atomic abstractions which they are not from abstractions, the most primitive type. We could see them on. So for example, we also have an expressive. So it has a piping syntax, as you might see. So for example, we have a JSON insert. It turns JSON in any abstraction, but you're defining two way of casting in just one syntax. So I'm gonna write this on OCaml. So let's get started. I'm working on the documentation website. So we are trying to do that. Image URL, the path, the image. Right. For view components and path image. Right. I'm just gonna take it. Let's go to VS Code. We can't do that. So the image src is public. I guess we could do something like that. Instead of public, just use .png. Alright, core concepts .png, which I don't really know where is that, so I gotta find it again. Does somebody write something? No. Alright, that's great. So I gotta find it on Joplin. Where is that? Kernels for notes for computer science, and here's the computer language basics. So we have an atomic that cannot broken down further. You know, it's just an atomic value, and every value is an expression. So what is an expression? Is anything in code can be evaluated to produce a value. So what is value? It's a data. It's the result of evaluating an expression, a concrete piece of data that can program use. So for example, when we do let x equals 5, the whole stuff is an expression. The value of it is 5. So when we do x, it returns 5. For example, instead of 5 plus 3. So here's the expression, and that's the value of x. So we are gonna evaluate that expression as 8. That's what the compiler does. I hope I could understand. If you don't mind the file size, you can use database. Yeah, I know, but I don't think that's great. That would be cool. Found that by accident by a feature. Yeah, I see that. I was using it, but that stuff is kind of same. Alright, so here's an expression. The true. Alright, let's go into the literals. So identifiers is just a variable name. For example, when we do let x equals 5 plus 3, here's the x equals the identifier of that. And what is a literal? It's just like an atomic representation of value. For example, when we do string, strings are just literal. So string is one of the literal types that we can use. Also, we have to compound expressions. My mother just gave me a cucumber. It's just multiple expressions. So, for example, true is a literal of Boolean. 110 is an int literal. String is a string literal. 2 plus 2 equals an expression, but it's a binary expression. So, and it all goes like that. So, I'm gonna be importing this into here, but we don't have any. Yeah, we gotta paste it. So I'm going into Joplin and creating a screenshot of that, and now I can copy that, or where's that file? Set as background. Shit, open with. Alright, where the fuck is that? Maybe in files, pictures, screenshots. Yeah, there it is. So I'm just gonna open VS Code in here and public, I think so. Public folder, maybe. Right. Core concepts, expressions. There you go, and we are going here. And we can't find it. Why? So we have 1 likes. That's great. So as that cannot resolve input. All right. You know what? Go white press public folder. Oh, gotta move public into docs, and it works now. Let's go back, and there you go. It's all working fine. So here goes the next, the data types. I don't know. I didn't define the data types yet. We don't have data types. It's just abstraction. So let's write it. Well, I'm just gonna get here. Considering this is going to be a kernel API, if my memory doesn't deceive me, there are some huge differences between an operating system and handle certain syntax functions differently. I didn't get what you're trying to say to me, but yeah, you're right. So I'm just gonna do something like that. Alright, and I hope this is going to be work. So how could I open it as a pop-out chat? Yeah, that's great. Could do something like that. Oh shit, I can do. Well, so we're gonna write some data types. Data types. All types are an apps. Oh, we already wrote it. So we have some data types in here. I know. Binding, composition, semantics. Yeah, I could copy that. Or no. Data mutation, type castings, exchange abstraction, syntax rules, bidirectional casting, defining types, casting, conditionals, data types. All right, defining types. All data types can abstraction definition. All data types are just an abstraction of atomic values. So we have atomic values in here. But where? Can't find it. Abstraction char. Right. Right, I see it. So we have primitive abstractions. Level 0, the primitive abstractions. Abstraction, character of char. Nope. Level 0, atomic abstractions. Atomic values does not an abstraction. Does not abstract something else. So how we can define? We can define else. So alright, atomic value definition. just say atomic define a value of atomic and take an expression reg expression. Right, I don't know how could I do an int expression over here, so we're just gonna, right, I'm just gonna say int, this is an x, this is r. Right, I'm just gonna go there in here, and I'll go into the chat GPT, or can you give me reg expire for defining int data type? So let's see. Where's our chat? There's 4 views. That's great. So here we can just restore it. I'm trying to remember the precise reason multi-OS support wasn't possible natively. It's not. What even is Perplexity? So it's an AI search engine. It's a search engine with AI. So welcome, by the way, the viewer. So the integer is something like that. So let's go back in here. Nope. Let's go back on VS Code. And let's go to end of it. And there you go. Now it works fine. Hi, Apple. Alright, define an atomic value. Define an atomic of regular expression of this. So represent all possible integer values. Let's go back more in atomic representation. Right, we're gonna define it a lot. Atomic values in computing doesn't recommend. And alright, common atomic data types. So define them in this syntax. So we are defining our atomic values. Alright, where's that? Already given, and the boolean is lowercase true or false. Is a regular expression of true and false, which is actually okay. And we are gonna define the char. If you want to allow escape sequences, there you go, and float, double. Also want scientific notation, right? Could do a scientific notation. So we defined all of our represent all possible So let's go to abstraction definition. So also we gotta go into the syntax. HPL. Define atomic name. It's an expression of reg expire rejects. Alright, that's the definition of it. So it works now, I think so. Let's go to atomic definition and we're gonna do syntax, abstraction, name of type, which value. Expression value type t string Alright, the work session is complete. We're gonna give a quick break. So the keyword and abstraction. Keyword abstraction. Can you write more? You just go to cloud. I want to complete it. And we're gonna go into a short break. I want to check. Also, what keyboard? It sounds like funky, so I use Ella F75. That's the keyboard what I'm using right now. All right. So, oh my god, it wrote everything. What the hell? Bro, stop. No, that's a lot. Type classes, compare monad. We wrote a lot. Wow. How about writing that in ABNF? Yeah, we could write that stuff in ABNF. That will be better. So the definition, abstraction definition, type class definition, and comment. The atomic type is something like that. The regex pattern. The abstraction definition. Oh my god. Don't go so far. We are doing a markdown document, so don't go so far. Make it simple to understand. Alright, let's see what it's gonna give us. Can't go there, there you go. It even has an yeah. It went so much. Just put you in here. So, alright. It's better. So what do we have? So we have the Boolean values and text strings. We could just go in here and change. Here, it's just here. Alright. So the abstraction name of type which condition. No, it's not a condition. So abstraction let Ukrainian define the types by. Alright, I'm not gonna do that. Simple atomic abstractions in positive integers only, neutral, positive, negative, byte, digit, percentage. Alright, I could take that. I could get that. There you go. The string pattern abstractions, which that's a lot. parameterize abstractions. Maybe we could just pass our Joplin in here. The domain abstraction, alright, we could just do that. Oh, we actually don't have to do that. I see. Alright, I'm just gonna go abstraction, my abstraction person of type, which of type, which it's a value of, yeah, I can just do that. Abstraction person of type equals type. Oh, we are declaring our type again. Type which it's an anonymous type actually, just it is, and where's our condition? No, just value. Abstraction name of type T, which, alright. So value of T, value abstracts T. Yeah, that's a better, I think so. It's a better definition for us. So it has a name as of string, and it has an age of int of positive int. Yeah, there you go. And 32. So we could just say that, yeah, we define our first type. We define our first type. Maybe just positive. It just goes like that. Alright, I'm not gonna deal with that. I'm gonna take a break. Where's the live stream? My boy, go take a break. Yeah, that's really good. You're way past. Yeah, I know that. I gotta take a break. Right. Do you have a Discord, by the way? My Discord name was I don't remember. 90. All right. Let's get a code breakdown L. Yeah. Here it is. There you go. Smarty. Alright, I'm gonna copy it. I'll be back. So let's start our timer. Start. Alright. Alright, I came back. So it's work time. So let's open Discord. I guess. Oh, what happened? Oh. Okay. Well, let's go back. So I'm just gonna start my timer again. Alright. So we are going back in here. We define our. Now we've been defined our first type. So, well, how about that? Core concepts, the basics, the hello world. Well, we didn't. Alright, we have command literals for some reason. So commands. Thus, we actually know that the hello world. Alright. How does Ziglang actually doing? And I want to see it. Ziglang.org. Documentation. Hello world. Hello, that's Zig. Alright, it's just it is. Hello world commands. Alright. So how it shows it? Types, free type of commands. Alright. So for printing into S3N, we could use print function from S3lib. It auto imports by default print. So we have hello and S into printf and world. So here. Yeah, we could do something like that. Apple. Don't worry, we are going to learn pipe syntax, piping syntax on the next chapter. Right. So we got 10 views and 6 concurrent viewers. So don't worry, we are gonna learn the piping syntax. So if you're already asking what is the piping syntax, so that I'm just gonna open the Joplin and let's go here and casting operators, type castings. Sorry, operators, application operators. So we have a variance of application operators that's the piping. It's always comes to first, always left to first, and always pipe to last. It always pipes to last argument. So that's the definition of abstraction. Printf. It takes string of lambda, string s of string, and format of string, and it takes type. It takes a list of types. Any type, right? Args of format of strings arg of any type. So it works just like that. So abstraction printf. For nerds. And where is it? For nerds. Oh. Yeah, there you go. It's better now. So let's see how it looks like. Weird to me that it needs to be called like that. It's a new way of programming, so yeah, it could be. It's not weird to me because I read OCaml, and to OCaml it's okay, but I get it, but it's weird. It could be weird. Life is weird. Right. Get started. The data type, it looks good. Comments and literals in hello world. For nerds, abstraction printf of lambda, format of string, args of any type. Any type. That will be better. Alright, so we have comments and literal section. So, commands and literals. I didn't think about that. Do we have literals? Nope, we don't have. So, let's go on in. Commands and literals. Commands and literals. Comments. Alright, let's go back to Zig. How they are doing that. String and literals, values, world and commands. Alright. Used by the compiler. Alright, I'm just gonna copy it. You know what? I'm just gonna steal it. It's public domain, so I could just copy and paste it. Alright, just do it. I did. Supports 2 types of comments. Right, we are also gonna support 3 types of comments. We are just stealing it because we can. What do you think about that? Can we do that? Can we just steal it? Yeah, we can do it. But I don't know what syntax that we are gonna use. So I'm using Python like, and I don't know multi-line and function documentation commands on Python. Alright. So multi-line and doc strings. So Apple, this is a one-line command. This is a multi-line command. And yeah, we have 2 types of commands. Maybe that will be better. What can we do? DD. Alright, do something like that. This is a documentation documentation command, which is going to be used in compiler. Doc generation. Alright, I'm gonna ask what kind of syntax we could use. What kind of document syntax could be used for my programming language? Yeah, we could do it as just open source, so I could just take it and, you know. Alright, example. Restructure text. What the hell is that? Oh, I see it. Yeah, that's better. Alright, that looks good. Alright, we could use it. We're just gonna go here, and there you go. I guess we are done. Command literals, yeah, but that's command and literals. No, just commands. How it looks. Three type of comments. Normal comments are but doc comments and top level doc comments are used by compiler to generate the package documentation. Well, we're gonna do the exact same. So that would be cool. We have hello world. Alright, I'm just gonna go into the white press again and the config section into here, and I'm gonna paste the hello world at the top and the core concepts, hello world, data types, and command and literals. So I also want to do a literal, yeah. Good. So let's go here, commands and literals. So literals. Yep, just that. String literal APL abstraction my str of string which this is a string. Abstraction my char of char which a string char multi-line string, maybe multi-line string abstraction multi-line of string which is just like that. This is a multi-line raw string. So bool, and we already did that, aren't we? Already did that. Let's go to basics. Nope. Casting. Where's our get started? I mean, were we just holding? Wait a minute. Where's the getting started? Guide. Oh right, that's in guide. Why? All right. Basics. We already defined that values, but I guess we gotta do back again, right? Yeah. All right. Boolean. Honestly, you can just do everything that manner. Monoline, multi-line. Yeah, that's right. Should I use ChatGPT for that? Yeah, just complete with ChatGPT. Just, alright, you know what? Just complete the doc. It's just so boring and I have 2 days to complete everything, so I'm just gonna use ChatGPT for that. And it's done. Data types, command and literals. Yeah, there you go. Yeah, I'm just gonna use AI. Okay, there you go. And it looks cool. All right. And float. My float of right, that's done. So we have 4 concurrent watchers. Go back in here. What is abstract programming? Why? PL compiler installation. Hello world. Core concepts. Syntax. Define atomic name. Regex. Abstraction definition. So the abstraction person of type fetch name. I've got to write yeah, it's a multi-line. So we have function definition. At least I wrote something for that. So I'm just gonna update it first. Basic add basics feed basics add basics. Also that sync the changes. Also get push code bark main. Okay, that's great. So close all. Go to functions, lambda, definition, and parameters. You know what? We could just do it on just one file. I think so. Yeah. Yeah, that's a lot of files. It's so complicated. I'm just gonna do it on just one file. Alright. So we have functions in here. Right. Nope, we don't have that. Function declarations. Now I'm talking. Function declarations. So the functions can declare when 2 main styles and the same lambda style. Alright, function style abstraction, the block form. Sorry. Just go into here and just say functions.md. Parameters. Alright, we have definitions. Lambda. We don't need lambda, but we need parameters and return types, I think so. We don't need that. Just delete everything. Functions. Alright, we could just simplify it. Let's go back into our. So you can froze. Oh, it happens after some while. Which I don't know how I'm doing it. I'm gonna do it. I don't want to break my OBS and end stream. So I guess we're just gonna be without camera. So we already have 5 minutes left. The time has passed so much. So let's get started back again on functions. Let's go to config, and we don't need that. Function definition, and where is the sidebar? Yeah, we just have sidebar. Let's go back in our local host. Right, now function definition. Lambda style functions can be declared with 2 styles. One, lambda style, expression form, abstraction name of lambda, arg1, ab2. Alright. Example. Abstraction name of function, and it's, yeah, we're fucking up, and that's here of return type, body statements, yeah. We have a body statement of like something like this without style syntax. So oh no, we're just declaring a return type. Yeah. I'm gonna suppose to declare that. Alright, so you know what? Don't use ChatGPT, guys, for that. I don't know when did I create it. Alright, first off t r2 of t2 and ret. Alright, you know what, just do that. Turn type and body statements. That's, there we go. Lambda func of lambda arg1 arg2 expression arg1 t arg2 t an expression. We actually had a better pose to go in the bottom. Where is that? Lambda Fury function declarations. I can't believe that I did that silly stuff. Well, I'm over here thinking, how should I design my database for one? I don't know. You can show us. We could see it on here, maybe. Right. Let's go back. to here. So yeah, let's go to definition, Apple, and functions are the, what is a function? It's a calculation, reusable calculation. Functions are the reusable. It's time for a break. Reusable mathematical operations in a box, which can take input and output. Mathematical operations in an abstraction, which can take inputs and give outputs. So in Bulgaria there are two types of functions. Lambda and Turing. Alright, I'm gonna give a break. Alright, we could start again. I wanna end this. It's like a bookstore. So the idea you could do. So, do you wanna write your own DB or use a DB? Okay. So. Let's write more. Lambda and Turing. So lambda functions are from lambda theory and comes from and functional programming. All lambda functions are just expressions. They're just one expression which can evaluate into a value. So they're good for quantime evaluation optimizations. Right, so the definition, example, abstraction and of string. Of lambda f equals an int. Lambda, no, that's not how we're doing that. So it takes an f of int and returns. We could just actually bind them, so we don't need that actually. We could just do simply bind abstraction and string of lambda, and yeah, it can be like that. It can be like that, but we are just gonna do int of string of lambda. I don't remember how we could use functions. I just don't remember that. I gotta check on my notes. So we actually wrote some function declarations, and I guess they were yeah, I was wrong. I was wrong about that. How we were doing it? So yeah, we were doing that. Yeah, defining types. Array list. Application operators. Defining types. Add a binding. Bidirectional casting is lambda c. No. Lambda str takes an str. Right. Could do something like that. F of int. Or just do that, yeah. But yeah, it takes a type and it takes something like that. And s of string. Lambda x of int match x f arg1 t x of int match fx as alpha of f true and false. Yeah, it goes like that. Or we could just simply can do that abstraction add add of lambda a b equals a of positive and of positive and how about a more compact syntax? A uint a of uint b of uint returns us the uint again, and there you go. It looks better. Uint a plus b. The return type an expression. T return type an expression. I gotta sleep actually. I'm kinda sleepy right now. UserDB ain't crazy to make my own. You could use SerialDB. So you could use that, guys. It's kind of cool. If you want some free database, you could just use. By the way, this thing is kind of cool. I'm following it for 2 years now. It also has its own cloud, but you could just use MongoDB as well. Oh no, SerialDB is faster than MongoDB actually. It's built with Rust, so it's fast. Right, Turing C-like. Classic Turing functions comes from Turing theory. Functions, Turing state machine. Turing state machine theorem. Right, lambda calculus. comes from the lambda calculus. Trig state, where it comes from, which every entity is an instruction to run states. Every entity is an instruction, aka state, for manipulating the current state of machine. So it's more this if you're coming from the C JavaScript, what all kind of popular languages you will be familiar with that already. So definition, simple syntax, Apple abstraction, my function of lambda arg1 of my function lambda function. Oh, right. My function of lambda arg, oh, it's not on a of function of function arg1 of t arg2 of t, return type block blocks more blocks instruction example body statements, yeah, statements. Example, abstraction, let me check the chat. I may use SQLite for now until I find something better. You can't, so you have to also host your SQLite database in cloud if you're gonna use only the free stuff. So it's hard for deployment. So abstraction add of function arg1 of t uint arg2 of uint and return type of uint. 32. return a plus b. Let abs a of uint which total which a plus b. Return total const total of yeah, that's great. So we have variables and mutations, we have operations, operators. So I will just go there as the application operators, which so I'm also going back to config, and we have basics, I download functions. So we have variables and mutations. So we are gonna go into the all the pipe operators into just one. So I'm going to application operators pipe operators. Okay, operators pipe. There we go. It should be better now. I'm just gonna go into here and application operators. Alright, I'm gonna copy it and paste it on operators.md. Operators pipe reference. No, not this one. Operators pipe. There you go. So alright, I'm gonna close. I can host an SQLite database because I have a VPS, the same provider. I will ask you, how many people are going to be use it? Update and add examples. Go by example for each operator. Left. Define what it does. Hydra. Alright. Oh, it's just simple stuff. Yeah, just stick with the SQI. Which language are you using? Well, ASCII tables. Nope. Oh. Nest.js. Nest.js? Is there somebody still writing it? Oh. Well, it's time for a break. Alright. I'll just quit writing everything in JS because my classmate... How old are you? Are you going to university college? I mean... Well... DuckDuckGo Nest.js. I never heard it for 4 years. Oh my god, they are still writing Nest.js. Wow, they updated the website. I mean, I was creating so I was writing a Maria web framework Cargo. And Cargo. So Cargo or Kratis I was creating a web server about 2 years ago. A simple Express.js like web framework built in Rust. So it downloaded 6,000 times for some reason, which I don't know why. I guess just bots are downloaded it. So yeah, it was working good. It still works actually. Vocational school professional technical developer. I don't know what the hell is that. Anywhere, everything from front and physical service setup, everything about everything. I see that. Well, let's go back in here and summary table. Yeah, it looks fine. Compiler guarantees for all operator compiler ensures the type safety, semantic consistency, proper abstractions. Yeah. Well, I'm gonna complete with AI. Any other documentation I don't want to deal with, I want to write a compiler. So I'm just gonna complete the other stuff from AI and repetitive operation, recursion loops, iteration, tail call, conditionals, pattern matching, insurance. Do we have insurance? Insurance. No. We need also the insurance syntax as well. So I want to say goodbye to you for now. I'm gonna open another stream tomorrow, probably in that times. So I hope you enjoyed it. Thank you for watching this video and the stream. So I'll just upload it after editing. So alright, let's end it. There you go.